We're going to talk about the GM system as well as the Dodge system itself. We'll focus, when we get into the details themselves, since they're very similar, we'll focus on one of the two systems themselves to take you through the diagnostics and the processes that you need to follow to help you with identifying issues that are typically misconstrued as being transmission-related issues when you're dealing with the fuel management control system themselves. This system itself, lots of different terminologies, as you can see right here, AFM, DOD, MDS, they basically are all the same system. So what it boils down to is there's different terminologies depending on the year of the vehicle and, of course, the make of the vehicle. So realistically, don't get confused when you start looking at the different terminologies because they basically mean exactly the same thing. We'd like to thank our sponsor, Seal Aftermarket Products. They've been with us since we started the webinar series. And again, we'd certainly like to show our appreciation to those guys for helping us out so we can make these things available to you guys free of charge. If you have any questions regarding ATRA membership or technical questions that you have regarding what membership basically is and how it works and so forth, please give the technical director a call or an email. His email is lwiggins@atra.com. Now we're going to do a little bit of housekeeping. Most of you guys have been with me for many, many of these, so this is kind of redundant for you. But for those of you guys that are brand new to this, make sure you have a hardwired connection, not something through a router. We've had lots of issues with routers with these systems, so just be aware that if you're having any type of audio or video problem, that could be related to the fact that you're not hardwired. The handout itself, everybody should have received. We went to a new format for delivering the handouts. Everybody seems to like that format. It is still a PDF style handout, so you're going to have an Adobe program to physically be able to open it or print it. Questions, if you have a question as we're running through any of the information today, feel free to ask it. The simplest way to ask it, bar none, is to pop the questions up on the questions box itself. Basically what it boils down to is you're going to click on the questions box and open that up, type your question in, hit the submit key, and it will automatically pop up on my screen. So I literally can't miss the question there. When we're all said and done with everything today, guys, we're going to be doing a survey. Survey just gives us some feedback on how the transmission went and so forth. If you have any ideas of things you'd like to see us cover, we'd sure like to hear that back on the survey from you. Now, our next presentation is going to be on the 26th of February. We're going to be doing the Dodge and General Motors new venture transfer cases. So we're not doing Ford because they're not a new venture style transfer case. We'll be following that up at a later date with the Borg-Warner style transfer cases that Ford and GM run. So again, different presentations because there just was no way for me to get enough information in that short a period of time through to you guys. So, you know, we're restricted to about a half an hour, 40 minutes or so with our presentations. Try to keep it during our lunch hour. So needless to say, we're going to be concentrating simply on the new venture style transfer cases. It will be the auto style transfer cases that many of you have had lots of experience working on. We're going to take you through how they work, all the little tidbits you need to know about service on them and so forth. So again, that'll be on the 26th at the exact same time here that we're dealing with today. So with that said, hopefully everybody can attend that. I think you'll enjoy it. And again, I'd like to shout out to the guys at GM Powertrain. They always help me out with pictures and everything for our presentation. So again, thanks to those guys in Pontiac, Michigan for giving us a hand. You may be wondering what this Active Fuel Management System or DOD or MDS system is all about. Well, here's the basics of everything. One of the things that the manufacturers are rated on by the federal government is fuel economy standards. They call it a CAFE standard. It stands for Corporate Average Fuel Economy Standards. The manufacturers have to meet that standard or they face a fine from the federal government. Well, the fines, of course, are pretty substantial because they multiply that over your total number of production vehicles in that given year. So you're talking about a healthy chunk of money here that you can end up getting fined if you miss the standard. So every manufacturer out there is trying their best to meet whatever standard the government basically imposes. And one of the systems that they're using to do this is this fuel management control system we're going to deal with today. The system itself is automatic from the customer viewpoint itself. It's a seamless system, operates between two different modes of operation. You can see this on both V8 engines and also the V6 engines themselves also use active fuel management or MDS system operations on those applications. So this thing's going to operate between V8 mode and 4-cylinder mode seamlessly to the customer. So, you know, I've got one of these trucks. I've had one since they came out, and so I've owned several of them. And you can't really tell when this thing is actually transitioning between V8 mode and 4-cylinder mode. You can watch it on the onboard display, but you really physically can't feel anything per se. So it is very smooth in its transition. The V6s, like you're seeing in the passenger cars, are the same exact way. You really can't tell that it changed over modes on you. So effectively, there's not much compromise, if any compromise, in engine performance, because if you step on the gas at all, this thing will automatically come right out of 4-cylinder mode and go back into either V8 mode or V6 mode operation for you, depending if you got an 8-cylinder or a 6-cylinder engine. So you may be wondering to yourself, well, if this is such a great system, why are we talking about this? We're talking about this because we have people who misinterpret a transmission problem when you actually have a problem with one of these subsystems on the vehicle. And this subsystem we're talking about here today is no different than anything else. So you can end up with misfire issues, vibration types of problems, and all sorts of different weird stuff that, again, people misinterpret that's actually a defect or a problem within this system, not a problem in the transmission side of the coin. So that's the reason we're concentrating on it here today. Now, as I told you, we're going to talk about both the GM system and the Dodge system today. Here's the GM trucks when they were first introduced. You can see it was introduced in the T trucks clear back in 2005. It moved over in some of the passenger cars in 2006, 2007. You've seen it coming out in the SUV applications, and of course, it's simply progressed since then. So, effectively, there's tons of these that are out there in all different types of platforms and vehicle applications per se. It is a different controller. Both Dodge and GM run different controllers for their AFM system / MDS system than they do a standard vehicle application. So you have to be careful if for some reason you're replacing the controller that you get the right controller, because again, they're going to have driver circuits to actually drive a series of solenoids to actually control the cylinder displacement on these engines. So again, we're talking here in GM. We talk about the E40 PCM. That was the first PCM that actually had those drivers built into it so that they could actually operate the solenoids. Bottom line is, if you've got two vehicles sitting side by side, one with MDS / AFM, one without, they're going to have a different controller in them. That's the basic bottom line with the whole thing. You're going to find there's some solenoids in these units themselves. Those solenoids are going to control lifter operation on the engine. We're going to house them in an assembly called a VLOM on the GMs. They're housed internal by themselves individually on the Dodges, actually in the engine block itself. So you're going to see that in a minute. We're going to deal with 8-cylinder engines here today, not the 6s, but the basic principle is the same. We can kill half of the cylinders on these engines. In fact, we will do that. We'll go through and kill the cylinders in the firing order of the engine itself to basically limit the amount of fuel delivery that goes through the motor, preferably increasing the fuel economy. They had to add some DTCs when you went to the MDS or AFM components. So again, you're going to see some additional trouble codes that are available for diagnosis of those systems. The base engine hardware on both GM and Dodge changed, and it changed pretty dramatically. What we're talking about there is the engine block. Severe changes as far as casting on the engine block itself was done to allow you to have this system on board. Here's the Dodge MDS. As you can see, it was introduced on the Hemis clear back in 04. It's progressed since then. I'm just showing you some of the different applications and how it progressed up. Again, very common system that you're going to run across. Now, the GM and the Dodge, and the reason I chose to put this together, these systems are built by a company called Eaton. Same company is now building the variable valve lift engines that are now out there as of this year. So probably next year I'll probably do a section on variable valve lift for you, where they've got the electronic valve train to actually vary the lift on the valve train itself. So again, same company builds that stuff, built this stuff. Again, called something different between GM and Dodge, but it's basically the same system. So very similar as far as operation, as far as everything else. Eaton is the basic supplier for everybody on these systems themselves. Your component names and physical construction of the components will vary a little bit, but the basic operation and the basic diagnostic processes will be the same. We're going to concentrate on the GM system so that I don't confuse anybody here, but I will show you some of the Dodge system and what some of the physical differences actually are. Here's a look at the MDS that Dodge has right here. Here's a cutaway that I got from the guys from Dodge showing you the Hemi block. You can see the roller lifter they've got right there, and you can see the solenoid cast into the block, obviously by displayed by the blue arrow that you've got right there. So bottom line, guys, is what's the biggest difference here on the GM versus the Dodges is how the solenoids are housed. The GMs actually house it in a manifold assembly. The Dodges, as you can see, they've recast the blocks themselves to house those solenoids internal. So those solenoids' jobs are going to be to turn on and turn off the lifters. You say, well, how can you turn on and turn off a lifter? Well, the lifters are hydraulically controlled by using oil pressure from those solenoids to actually make the lifter inactive or active. And I'm not talking about the lifter going up and down in the lobe. I'm talking internal to the lifter itself, and I'll show you a picture of that in a minute. So one of the primary differences that you're going to run across between a GM and a Dodge is going to be how the solenoids are actually housed. How the system works is almost the exact same thing from GM to Dodge. But as far as the look that you're going to see of the components, are going to vary a little bit. This is the lifter we talked about right here. So upper left-hand corner, you'll see a picture of the lifter. What I want you guys to note on that lifter is you see that looks like a roll pin on the inside of that lifter right in the middle of it. That is the pin that activates the lifter or deactivates the lifter. The outside of the lifter is the outer sleeve of the lifter assembly. And you can see there's a sleeve inboard of that outer sleeve where that locking pin is riding. When I push that locking pin in, the inner sleeve can move separate of the outer sleeve. When the locking pin is out or protruding outwards, the two sleeves are physically locked together. So that's what we're talking about when it comes to activating or deactivating the lifter. The lifter is still going up and down on the cam lobe, doing its own thing like it normally does. The difference here is the internals of the lifter either allow the sleeves to move as a set, so there's if the locking pin is going through the hole there, locking the two halves of the lifter together, or it allows these sleeves to move independently of each other. So that basically means the lifter outer sleeve can be moving up and down, but the inner sleeve, which pushes on the push rod, is sitting there stationary. So that's the basics of how this system is going to do its job. So when you look at the cam lobe that you see there, you see the two pictures of the camshaft and the lobe pushing on the lifter. That left-hand picture is showing that the solenoid does not have oil pressure going to the lifter. So without oil pressure going to the lifter, that little pin is pushed to the outside, locking the inner and the outer liners together. So when that happens and that lobe comes around and pushes the lifter up, it pushes on the push rod and the rocker arm, and of course the valve, as you can see, the valve is physically opening to allow air in and exhaust out. If you look at the right-hand picture, you'll see the solenoid is turned on in that right-hand picture. So with the solenoid physically turned on in that right-hand picture, oil pressure is pressurizing that center cavity of that lifter body, pushing that locking pin inboard, unlocking the inner and outer sleeve from each other. So that means the outer sleeve, which is attached to the roller of the lifter, it's going to be going up and down with the cam lobe, but the inner sleeve, where the push rod is at, that's not going to be moving. So as you can see, the valve spring is physically holding the valve shut, and of course the lifter is still going up and down, but there's no actual mechanical action at the valve train itself. Now this leads me to one really important thing, and that is service of these systems themselves. One of the things that the federal government has done, is they have come down very hard on the OE manufacturers regarding used oil. They view it as a massive contaminant issue out there, even though obviously, as we all know, people are recycling their oil, they're burning their oil in waste oil heaters and so forth. The government's not impressed with that whole program, so they have really hit the manufacturers hard when it comes to waste oil. So what does that basically mean to us from the service end of it? That means they've put systems on these vehicles, such as engine oil life monitor systems, that monitor your engine oil. Now, this is a great selling feature, but it's not really great when it comes to the service side of the coin. Most of you guys are aware people do not service their vehicles very well, and these systems here that we're talking about with these hydraulically controlled lifters like this and these electronic solenoids are very subject to problems with people not changing their oil. An awful lot of troubles that we see with either valve lifter noise or solenoid problems is related to the guy not changing his oil. Now, here's my 2 cents on the whole thing. I've owned several of these vehicles that have this system on it, have owned them since they've come out. So I've owned several different trucks and cars and so forth that have had AFM on it. I change my oil, I'll be perfectly honest with you guys, about every 3,000 miles or so, just like you did before. That's my words of wisdom to you. Even though you've got an engine oil life monitor system on board your vehicle, I would certainly not be running it to the end extent to try to gain every mile that I could out of the engine oil life. Again, I've just seen too much trouble with lifter contamination and so forth when people do that. So to me, oil and the filter, a good quality filter, are very cheap insurance. I buy good oil and I buy the best filters that I can possibly buy to make sure that I don't have problems down the road. So that's my words of wisdom to you guys when it comes to this whole thing. I realize that's counter to what the federal government says and why these engine oil life monitors are on the vehicles. But again, if you do not want to have problems with these vehicles, change your oil and use a very good quality filter and you won't have much trouble. So that's my 2 cents worth for the day here. Now, as we talked about, the controllers that you're going to have on these vehicles are going to be a different controller than what you had with a non-AFM or non-MDS vehicle. So here I'm showing you the GM controller, the E40 PCM. Bottom line is, just be aware that you have to have the driver circuits to drive those solenoids to actually operate those lifters. Many of the vehicles you'll run into are going to have some sort of vacuum monitoring system on it. Here's a brake booster vacuum sensor that we're showing you right here. The reason for that, guys, is pretty simple. You can't have a situation where you're putting this thing in the 4-cylinder mode if you already have low engine vacuum, because that means you're going to end up with a very hard brake pedal and somebody's going to end up in an accident. So they monitor the brake booster vacuum to make sure that the brake booster always has good vacuum. If for some reason the brake booster vacuum is not where it's supposed to be, then it will disable the active fuel management system or MDS system. Here's a look at the engine block. This happens to be the GM engine block. You already seen the Chrysler one. As you can see, the GM block also has some casting in it that's been redone. Cylinder 1, 4, 6, and of course 7. As you look at the block right there, you see those ports that are cast into it. That's where the VLOM manifold actually sets on top of to feed oil pressure into those things to get into the lifters. So these are casting passages that actually feed the lifters themselves. So it's a different block for a fuel management control engine versus a non-fuel management control engine. Oil pressure has got to be regulated because oil pressure is what runs these systems. So again, oil pressure is going to be really important. We're simply showing a pressure relief for that oil pressure system. Again, make sure your oil volume and your pressure and your condition in your oil are good before you start working on one of these systems. Here's a look at GM's version of those solenoids. They contain them in something called a VLOM, valve lifter oil manifold. As you can see right here, it's a die-cast housing. It's got an electrical connector plugged into it. You got an oil pressure sensor built into the thing in the back, and of course have a replaceable filter screen. Most people don't even know that filter screen's there. And so again, if you got a guy that's running dirty engine oil, he refuses to change his oil like he should. just like if you had a transmission solenoid, you're going to have a filter to protect that. So they put a replaceable filter screen back in the back of that thing that basically filters the oil before it gets into the solenoids themselves to try to reduce the damage to the solenoids from having dirty and contaminated oil in the manifold assembly itself. So again, most people aren't even aware it's there, but it is there and it's a serviceable item. Here's a look at the side view of that whole assembly we just talked about right there. You got 4 on and off solenoids. So we're going to turn those solenoids on and off based on firing order of the engine. Solenoid resistance, as I'm showing you right here, is about 18 ohms. Again, nothing different than you've dealt with before. Simple on-off solenoids. The difference here is we're going to have to turn them on and off in a firing order. The electrical bus bar that feeds the solenoids, again, just like you do for a transmission, you're going to feed power to the solenoids. We're going to control the individual grounds of the solenoid itself to control the operation of the solenoid. Now let's take a look at the lifters. So here's my lifters. The non-switching style lifter is on the left-hand side. The switch style lifter is on the right-hand side. So your MDS or AFM style lifter is the big one that you see there. That's a physically a different lifter than what you had before. So again, different as far as service and parts and so forth are concerned. Now, as I talked about a little bit earlier, that lifter actually has 2 sections, an inner liner and an outer liner, and we're going to have a locking pin that moves between those 2 sections. And oil pressure is used to move that locking pin to either lock the 2 sections together, making it a standard lifter, or unlock the 2 sections, which then makes the lifter telescope with inside the 2 pieces. In other words, my point is we unlock the inner from the outer housing itself, which then lets the lifter move up and down inside of itself without moving the push rod or valve train. So again, go back to the picture we did before. That locking pin we're actually talking about, you can actually see on the cutaway that I've got from Eaton there. That shows you the pin itself, and of course you can see on the inboard side of that outer liner, you can see the inner liner that we're actually talking about. And again, as I pressurize that solenoid then pressurizes the lifter, pushes that locking pin inboard. When I push the locking pin inboard, we then, of course, allow the inner and outer liners to move separate of each other, which keeps the valve train closed. That's the basics of how we're going to do this. In order to do that, we're going to have to be able to get the oil pressure to there. Again, you're going to have some casting ports that are built into the block. Again, whether it's a GM or a Dodge, same kind of principle. The only difference on the GM and Dodge is where they mount the lifters. Remember, on the Dodges, they mount the lifters, or I should say where they mount the solenoids. On the Dodges, they actually mount the solenoids right in the block. The GMs, they mount them into the manifold assembly itself. Now, there will be some criteria that you have to meet in order to get the MDS or AFM to work. This is GM's criteria right here. Chrysler's is almost identical to this. Transmission's got to be in a higher gear. You got to have some decent oil pressure. You can't be over-revving the engine, or you can't have the engine at idle. The engine's got to be warm. You got to have steady load. Now, I've driven one of these vehicles, again, since this system came out. And I can tell you right now, you do have to have a very steady load. Even if you do not vary throttle opening, if you hit an incline, it will automatically pop out of 4-cylinder mode and go to 8-cylinder mode. So let's say you're cruising down the road, flat road, you got your foot barely on the gas pedal, it's in 4-cylinder mode, as you can see that displayed on your onboard diagnostics, or with the scan tool, either one, and it hits a little bit of an incline. When MAP and MAF change, it goes, hey, we need to have some more power, so we need to turn the other cylinders back on. So it basically looks at load input just like you do for any other component on the vehicle, and if it sees that you have a load, it automatically goes back to 8-cylinder mode for proper operation. Now, if any of these things here happen, you're going to end up disabling your MDS or AFM. So if manifold vacuum's low, we just talked about that a little bit before. We can't have this brake booster running out of vacuum, so you got to make sure engine vacuum's where it's supposed to be. If you're on the gas pedal hard at all, you're not going to get AFM. Transmission shift is in process. We're certainly not going to turn it on when you're actually making a shift, per se. It's only when you hit cruise conditions. D-cell fuel cut. A lot of guys don't even know D-cell fuel cuts there. We've had this since Moby Dick was a minnow. In other words, this has been on vehicles since we've had fuel injection. When you go down a hill, you let up on the gas pedal. One of the things you may notice if you're monitoring fuel delivery is we shut the injectors off. It's just common. We don't want to end up pumping a bunch of raw exhaust out into the cat. So D-cell fuel cutoff basically shuts the injectors off for parts of the deceleration. Minimum heater temp, we'll disable it. We want the engine to warm up first before we allow the system to work. If you're operating in reduced power mode, and again, you've seen this with some of the diesel engines where you got reduced power mode. Some of the gas engines have the same exact thing. So if for some reason it's in reduced power mode itself, it's going to disable it. Torque management, if that's active, so in other words, if you're working the heck out of the transmission, it's not going to allow it to work. Piston protection mode. So in other words, we're going to look at the NOx sensor. If we see detonation, we're going to disable the system. Catalytic converter over temp, hot coolant mode itself. You guys have dealt with hot modes for a long, long time, since the early 1990s on the GM application. So if we are in hot mode, AFM or MDS will not function. As well as you can see a bunch of different trouble codes for all sorts of different stuff. So there's a lot of criteria, is my point, that will lock this system out and keep it from physically working. Now, when you look at the operation, whether we're looking at a Dodge or we're looking at a GM, it basically works the same way. This is a GM picture. We're showing a power coming from your fuse box down to the solenoids themselves. We branch that out through each of the solenoids, and then the controller simply controls the ground for the solenoid. Now, notice I give you the firing order, 1872653. When you in turn want to start canceling cylinders, we will cancel the next cylinder in the firing order. So we're saying if cylinder number 1 is firing, the next cylinder in the firing sequence that could be disabled would be number 7. So we're going to go through, we're going to kill those based on your firing order. So we're going to be turning the solenoid on and off to pressurize or depressurize that lifter. Now this is kind of a stumper for a lot of guys right here. We're saying by deactivating the exhaust valve first, we're going to trap the charge, the burn charge in the cylinder. So here's what we're going to do, guys. We're going to force the system into MDS or AFM at the point when you're on the intake stroke. So the intake stroke has been completed. At that point is when we turn these valves off, because we turn them both off at the same time. So that means the only valve that can't open in that firing sequence is going to end up being the exhaust valve. The intake valve has already opened. We're just going to make sure we keep it closed right at this point. So now we got that exhaust valve physically closed. So we've gone through our power stroke. So anything that's in that cylinder will be trapped in that cylinder. Now there's a rationale and a logic behind this. First off, what it does is it maintains pressure on top of the piston. So you're going to have some static compression maintained on top of the piston. That keeps the piston from rattling around in the cylinder bore, which then reduces piston slap. It also keeps pressure on the rings, which then reduces oil consumption. Now, we've had a lot of complaints with MDS and AFM engines, people complaining about engine oil consumption. You know, they've done a lot of studies on this whole thing, and they found out it's not related to either of these systems. What on the GM side it was related to was the piston design. They have very short skirt pistons in these motors, and what it boils down to is you have a situation where you got a short skirt piston and you got quite a bit of rod angle. The piston doesn't set necessarily right against the edge of the bore squarely like you'd like to have it, so the rings aren't square in the bore, so you end up with this thing wanting to consume a little bit of oil. Again, they've changed piston designs since these different generation small blocks came out, and the oil consumption thing's pretty well been handled. The other thing that you'll run into, a lot of engines nowadays, from GM, Dodge, Ford, everybody, are now running oil squirters. But basically what they're doing is they're squirting oil from the connecting rod, just like they used to do in the old days, right up onto the piston pin. So the logic is to try to cool that piston. So you'll end up with lots of oil going up under those cylinder walls. And again, If the guy's not changing his oil or he gets some carbon buildup on the pistons, you're going to have some troubles with oil consumption on these engines. So again, it's not necessarily related to MDS or AFM operation. It's related to other things that can cause the type of concern there. So bottom line is, guys, when we go into fuel control mode, we're going to keep that exhaust valve closed. When that exhaust valve is closed, that traps whatever that burned air fuel charge was right on top of the piston itself. We will disable the injectors so you're not injecting fuel in the cylinder, but we will keep the ignition system running. So the spark plugs are still sparking. The coils are still doing their thing. The logic or rationale behind that is to keep the tip of the spark plug nice and hot so that when you turn the injectors back on, you don't end up flooding a cylinder. So because of a cold plug. So we don't want to end up shoving a bunch of unburned hydrocarbons down into the cat, causing catalytic converter issues. That's the whole idea behind this. As you can see, the system can remain active for a given period of time, and it doesn't take long for it to activate once the parameters are correct. So 250 milliseconds or 2 rotations of the crankshaft, pretty quick as far as operation. You'll see some scan data on your vehicles when it comes to diagnosis that you need to know about. That scan data itself is used to help you with diagnosing of these engine issues. And I'm not sure, there we go, why it wasn't changing on your screen there, but there we got it. As you can see, we got commands for the cylinders, and we've also got cylinder feedback for the circuits themselves. So a lot of basic diagnostic information, just like you'd have for a transmission solenoid here. Nothing razzle-dazzle. You're also going to find that we have the abilities with your scan tool to override those solenoids. And that override function is going to become extremely important for you. So we're going to use this along with a vacuum gauge to figure out if, in fact, we have a solenoid issue or not. So here, as you can see, we got all the solenoids turned on. If I hit the off button right here, I can turn off those solenoids one at a time and physically see what actually happens with my vacuum at the engine itself to tell if that solenoid and lifter are functioning like they're supposed to. So what does it take to diagnose one of these? Pretty simple. The special tool you see there is a GM special tool. Dodge doesn't have that because they don't have the solenoid blocks like we got here. Do you have to own the tool? No. You can do all of this with a set of jumper wires if you want, and of course an air hose if you want to do it that way. The tool simply makes it easier for you. Vacuum gauge, your scan tool, oil pressure gauge, and the compression gauge, though, are essential. So here's an example of identifying a problem with this system. We're saying hook a vacuum gauge up. We're going to monitor the vacuum, and then we're going to turn the cylinder on and off with our scan tool. You should see some vacuum change if, in fact, that lifter and solenoid are doing what they're supposed to do. Because remember, your engine is nothing more than a glorified vacuum pump. That's all it is. And when you take a cylinder away, you should have some sort of impact on that vacuum pump operation. So if we see a change from a ½ an inch to 2 inches, we're happy campers. If we don't see any change at all, then we have a problem. Now, when it comes to the basic diagnostics, pretty simple. We want you to check your engine oil level itself before you ever start into one of these. So if you have a misfire complaint you think may be related to this system, which is obviously be misconstrued by your customer as a transmission-related problem, we want you to start with engine oil level and engine oil condition. Is this guy the type of guy that changes his oil, does not change his oil? That's going to give you a clue of where you're going to go. Look for trouble codes. They got a lot of different trouble codes. We can use an oil pressure gauge to verify oil pressure for the system, and we can use a compression gauge to verify whether those solenoids are actually doing what they're supposed to do or not. If you do have to service it, remember on the GMs, everything is in that manifold assembly, so you're going to have to go through and individually replace the lifters, but you have to replace the manifold assembly as a set, in other words, a complete assembly. The Dodges, again, you don't have to do that. You can simply buy a solenoid for it and off to the races you go. So let's look at oil pressure. It's real important we know that the inlet and the outlet pressure are the same coming out of that manifold. So what we're going to do is we're going to screw an oil pressure gauge into the sensor hole, and we got an adapter that actually plugs into where the oil filter's at, and we're going to compare the readings so that we know the inlet and the outlet pressure are identical, because that's going to give us an idea if there's a restriction in that manifold at all. So should be the same readings. The compression test that we're going to do is going to be a running style compression test. Now, most of you guys have done running compression tests for many years. This is not an uncommon kind of thing. The difference here is you're going to turn the cylinders on and off with your scan tool. So we're saying with a running compression test, your cylinder should build a minimum of 50 pounds. Most running compression tests, you will see at least that. You'll usually see 70, 80 pounds. If you got a couple hundred pounds of static pressure, you'll see 70, 80, 90 pounds of running pressure. So that's with all solenoids active, or I should say all cylinders active. When we turn the system on for that thing, you should see that cylinder pressure dropping to approximately 25 pounds or less. That means that the only thing you have left in that cylinder is going to end up being exhaust gas. That's the only thing that's there. So bottom line, guys, is this gives you a really clear, easy test to find out if, in fact, those solenoids and those lifters are actually doing what they're supposed to do. Now, you're probably saying to yourself, well, then how do I figure out if it's a solenoid or if it's a lifter? Well, first off, most of the time, if you got a lifter problem, you're going to have a problem with noise. We've had some valve lifter issues, again, usually caused by contamination, which basically means the lifter's not going to stroke the way it's supposed to, which then means you can end up with a misfire issue with it. You're going to typically have a clicking or a clattering style noise, just like you would any old valve lifter. So, again, an easy check there. Do you have any kind of noise? And it can kind of give you an idea. You can also check the solenoid assembly with a special tool. Same kind of process we did with transmissions. So we have a special tool, just like we would for a 6L80, 6L90, where you hook air to the solenoid assembly itself. Then you use your scan tool to energize and de-energize the solenoids themselves and see if there's air flowing through it. Now, again, if you don't have that special tool, you can use some jumper wires and switches or whatever to check those solenoids. So, again, this tool simply makes it easier for you. That's all it basically does. So that's the isolation process that they actually have for checking whether we got a problem with the lifter or we have a problem with the solenoid. Well, that pretty well completes our presentation for today, guys. Looks like we're right on time, 40 minutes. So again, I appreciate your attendance. Appreciate the guys from Seal Aftermarket Products obviously sponsoring us. I don't see any questions popping through here, so our next presentation, guys, is going to be on the 26th. And again, we're going to be dealing with the new venture transfer cases, not the newest transfer cases, not the MP transfer cases. This is the mid-2000 range type transfer cases that both Dodge and GM predominantly ran. We're going to deal with the auto-style transfer cases here because those are the ones that give people the biggest headaches. So hopefully we'll see you guys then, same time, same channel. Again, with that said, thank you very much and have yourself a great day.